Let's talk about the relative importance and potency of carbon dioxide and methane as greenhouse gases. So, these are the two most abundant and influential gases that contribute to the global warming and climate change. But how do they compare and why does it matter? So, first, let's define what we mean by potency. Potency is a measure of how much heat a gas can trap in the atmosphere over a given period of time relative to carbon dioxide. So, carbon dioxide is the reference gas, so it has a potency of 1, as you can see on the table on your left hand side. Methane, on the other hand, has a much higher potency than the carbon dioxide gas. So, depending on the time frame, methane can trap 28 to 87 times more heat than carbon dioxide. And this means that methane is much more powerful greenhouse gas than carbon dioxide per unit mass. However, potency is not the only factor that determines the importance of a greenhouse gas. We also have to consider the abundance and the lifetime of the gas in the atmosphere. So abundance is the amount of gas that is present in the atmosphere at any given time, and lifetime is the average time that the gas stays in the atmosphere before it is removed by some natural processes. So carbon dioxide has a much higher abundance and has much longer lifetime than methane. Carbon dioxide can also last for hundreds and thousands of years in the atmosphere, while methane lasts only for about 12 years. So this means that carbon dioxide accumulates more and more in the atmosphere over time, while methane is much more quickly removed. So, how do we weigh these factors and compare the overall impact of carbon dioxide and methane on climate change? One way to do that is to use a metric called global warming potential. The global warming potential is the ratio of heat trapped by a gas over a specific time horizon relative to the carbon dioxide. For example, the global warming potential of methane over 100 years is 28, which means that 1 ton of methane will trap 28 times more heat than 1 ton of carbon dioxide over a century. The global warming potential of methane over 20 years is 84, which means that 1 ton of methane will trap 84 times more heat than 1 ton of carbon dioxide over a decade. So, the choice of the time horizon is important here because it reflects how concerned we are in the short term and long term effects of climate change. So, if we care more about, let's say, next 10 to 20 years, then we should focus more on reducing methane emissions because methane sets the pace for warming in the short term. But if we care more about the next 100 to 100 years, then we should focus more on reducing carbon dioxide emissions because carbon dioxide determines the long term warming trend. And of course, both gases are important and we should aim to reduce both of them as much as possible. But the time horizon helps us prioritize our actions and allocate our resources more effectively. So, if I want to summarize, so carbon dioxide and methane are both greenhouse gases, and both of them contribute to the global warming and climate change. But we have to be mindful that methane is more potent than carbon dioxide, but carbon dioxide is more abundant and long-lived than methane. So global warming potential is a metric that compares heat trapped by a gas over a period for a specific time horizon relative to carbon dioxide. And the choice of time horizon reflects how concerned we are about the short term and long term effects of climate change. Thank you for your attention.